Okay, we saw earlier that if we did this integral, we got 124 over 3. If we did u sub, we got the same answer. Well, why is that? I'm going to talk a little bit about the geometry and then the algebra. So basically, if I graph this, look at the area between 0 and 2, which is what an integral does. We'll talk more about that area, later. That shaded area is 124 over 3. Well, if I do this thing, I'm graphing y equal u squared on the u-plane. So this is my u-plane, but that's my main variable. This is my x-plane. So if I graph this function on the u-plane between 1 and 5, look at that area, that's the same thing. So I've kind of magically transformed this function into a different function with different variables that has the same area. And so that's why it works. Now why? Well, that's what I'm going to talk about here. I'm going to use symbolic language here because I'm trying to prove something. Again, you don't have to worry too much about all the details here, but I want to try to explain it in a theoretical way. So basically, here's an integral. That's the kind of integrals we've been doing. That's basically what this example over here was. Remember, u was x squared plus 1, and this was 2x was u prime, and then we had our dx over here. So that's the way it was set up. So I do my u sub, and that transforms the integral into this. I still have my x's over here. So u of x is the same as u prime is the same as du over dx. These mean exactly the same thing, but the symbology I think helps us a little bit, because when we rewrite this as this, the dx's cancel. So we're left with u squared du. Now we still have the x variables here, but I'm going to do that transformation just like I did over in the problem before. So when I got these numbers for u2 and u1 from my x values, I'm doing the same thing over here. And that's what I end up with. So basically, I've preserved my equality the whole way. I've used algebra to change a more complicated integral into a simpler integral. And so what I'm trying to say here is that this is the algebra of why we get the same answer. And really what we're saying is that integration by substitution preserves the area, so it doesn't change with the value of the integral, but it changes the function. So we're integrating different functions. So again, we do all this transformations. This is a symbolic way of looking what we're doing with the u substitution. This is what we get. So I hope that's helpful. I can talk more about this in class if you'd like.